Hey guys, hope you're well. So in this lesson, we're going to be talking about the perimeter and area of rectangular shapes. Now, when I say rectangular shapes, I'm not only talking about, we're just going to look at easy examples like that. What I mean is we're going to combine rectangles. So we're going to have shapes that do, for example, like that, like that, like that. These are all rectangular parts. So that's like a rectangle. That's a rectangle. So I'll show you some of the examples we're going to do. We're going to look at examples like that and like that. So here's our first one, just to cover the basics. So let's talk about perimeter first. Perimeter is the distance on the outside. So if you had to walk around the shape, you would walk over here. You would walk over here. You would walk over there, and you would walk over there. That is the outside. So the perimeter, you just add those numbers together. So this would be 8 centimeters. So 8 centimeters plus. Now, the opposite sides of a rectangle are the same. So this would be 3 centimeters, and this would be 8 centimeters. Because this length is the same as this length. So you're going to say 8 centimeters plus 3 centimeters, whoopsie, plus another 8 centimeters. Okay, so we've done that one, now we've done that one, and now we're going to do this one, so 3 centimeters. And so if you had to go add all of that up, you would say 22 centimeters. You won't say 22 centimeters to the power of 2 because we're not looking at area for that part over there. Now, if we had to look at area, so area is, well, you could think of area like this. What we can see is that they say that this length is 8. Okay, now maybe you know area very well, then you can ignore what I'm saying now. But for those of you that are maybe like, what is area? Well, let me show you. So let's say it says 8, okay? So I want you to draw, we're going to make sure that there are 8, not 8 lines, but you'll see now what I mean. So let's just do that. Trying to make these, just pretend that these are equally spaced. Okay, we're going to have to do that again. Okay, so there's 8 different plate parts. Can you see here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 parts. I'm not saying that there's 8 of these lines. No, you can imagine this as a certain little part. This is a part, or like this is a little area, this is an area, this is an area. So there's 8 little areas, okay? Now, going down this way, I want you to make 3 little areas. So the way that you'll do that is there and there. So there's 1, 2, 3. Okay, now how many blocks are there? Well, you could go count all the blocks. You could say this is 1, 2, 3, 4, 5, 6, 7, 8. And what you would find, 9, 10, 11, 12, blah, blah, blah. You could go on and on and on. And what you would find is that there are 24 blocks. So what is a faster way, instead of having to go count all of those? Well, the fastest way you could do that is to just think about this like this. You've got, there's different ways you could do it. If you just look at this whole row, how many are there? There's 8, right? Now, how many rows are there? There's 3 rows. So what is 8 multiplied by 3? Well, that is 24. And that is exactly how we work out area. You could also say that there are 3 this way, and there's 8 of those. So what is 3 multiplied by 8? Well, that's also 24. So area just tells you how much space do we have inside here, okay? And so a faster way to do it for a rectangle is just to multiply these 2 lengths. 3 multiplied by 8, so let's go do it now. Area is just 3 multiplied by 8, and that would be 24 centimeters. But now you say to the power of 2, because you are multiplying. And so you could think of it like this. You could say 3 centimeters multiplied by 8 centimeters, which is 24, and then centimeters and centimeters gives you centimeters to the power of 2. Here's our next example. Now this one's going to be quite interesting because if you look at this shape as a whole, that is not a rectangle. So when we look at the area, things are going to get a little bit weird. For the perimeter, remember, perimeter is on the outside. So it's everything on the outside. So here, here, and there, and there. So that's perimeter. So you just go add everything together. But what you're going to notice is that, so let's quickly take all that away. We can start here, for example. So we could say that the perimeter is going to be 18 centimeters. Okay, so we've done that part. Plus, then we can do this part over here. So that's 4 centimeters. Plus, now we need to do this part, but we don't have that part. Okay, now some of you would be quite comfortable with knowing how to get that, but some of you might find that a bit tricky. So let me try to help you. What you can do is, if you look over here, this length here is 8 centimeters. So what I'm going to do is I'm just going to put a dotted line over there. So this length from here to here would also be 8 centimeters. Can you see? These two must be the same. Okay? Now we also know that this entire piece from this entire length over here must be the same as this one. Must be 18. So this from here to here is 18. So then this part over here would have to be 10. Now you might need to pause and just make sure that you agree with me on that you understand how I did that. This part here must be 10. Okay, now we can take all of this away. So we can just say plus 10 plus. Okay, the next part we're going to do is we're going to go down to this part over here. Now once again, we don't know what that length is. But we know that if you look here, this is 4 centimeters. So I'm just going to do that, because then this must also be 4 centimeters. Now the entire length from here all the way down to here must be the same as this one, which is 10 centimeters. So if this part here is already 4 centimeters, then this part here would have to be 6 centimeters. Well done if you got that. If you didn't, just take your time, pause the video, give it some thought, and you'll see that it is true. So this part is 6 centimeters. So we can add 6 centimeters over here. So we've done that, and we've done that. Now we can take this away. It's not actually part of it. Okay, now the rest is easy. We're just going to do this part. So that's over there. So let's just say plus 8 centimeters plus, and then this part. And so let's just say 10 centimeters over there. Okay, now if you had to just go and add all of this together, you end up with 56 centimeters. You're not going to say 56 centimeters to the power of 2. That's only for area. Okay, speaking of area, that's what we have to go and do next. Now for area, you cannot find the area of the shape in one step, because that is not a common shape. It's not a rectangle, it's not a triangle. But what we can do is we can, for example, there's many ways you could do this. You could, for example, put a line over there. Then all of a sudden we have 2 rectangles. You've got one over here and you've got another one over here. This one might end up being a square, but that's okay. We know how to calculate the area of a square. So you could do that, for example, but you don't have to do it that way. You could also put a line that way. And so then you've got 1 rectangle and 2 rectangles. If you really want to make extra work for yourself, you could put a line there, you could put a line there, and then you've got 3 rectangles that you have to go calculate. It doesn't matter. At the end, all of our answers are going to be the same. So I'm just going to do it this way. Okay, so we've got 1 rectangle there, and then a 2nd rectangle over there. And so if we look at this first one, that rectangle, remember I showed you in the previous example that we did, to find the area, you just want to multiply one of the lengths going that way and one of the lengths going that way. So for the area, for shape number 1, it's going to be 18 centimeters multiplied by 4 centimeters, and that's going to give us 72 centimeters squared for that part. And then for this part over here, well, that's going to be this. Now, be careful. Some learners use the 10, but you cannot use the 10 because the 10 is all of that. But we are only looking at this blue shape. So you could look at the 8. That's going that way. That's perfect. 8 centimeters. And then you could look at the 6, okay? Because that's part of the blue shape, like like that. And if you had to multiply those two, you'd get 48 centimeters squared. Now what you're going to do is you're just going to add these two numbers together. So the area of number 1 plus the area of number 2, and that's going to give you 72 plus 48, and that's going to give us 120 centimeters to the power of 2. Here is our last example for this lesson. So we're going to do the perimeter and the area once again. So we could start, or let me just first say here, perimeter. And so we could start with this part here at the top, which is 9 centimeters plus. Then we could go to this part over here, which is 6.8 centimeters plus. We could then do this part over here. Now this drawing was a little bit weird to try see what is what, so I made it very clear over here by saying that it is AB, that it's 5.5. So we could say plus 5.5. Now we've got this little piece here. Now we don't know what the length of that little piece is. So what we can do is, if you look at this length, that length is 16. Okay, so that's 16 centimeters from top to bottom. Now, if you look from here all the way down to here, that would also have to be 16. So if this part here is 6.8 and this part is 6.8, then what would this part be over here, this length over here? Because if we can find that length, then we've got this length, because they would have to be the same. Okay, so we could say 16 minus 6.8 minus another 6.8, and that'll give us 2.4. So then we would have 2.4 centimeters over here, so 2.4 centimeters. Okay, and so that would mean that this one here is also going to be 2.4 centimeters, this part over here and over here, they're the same. Okay, so now we can just keep adding, so this would be 2.4, so we could say plus 2.4 centimeters plus. Now we could say, now we need to go to this part again, so we could go there. And now that's just going to be the same as AB, so that's going to be 5.5, so we could just say plus 5.5 centimeters plus. Now we can do this part over here, which is 6.8, and then we can do the, which part? Oh, that. So this part over here. Now that part is going to be the same as this part. They would have the same length, so we can just plus 9 centimeters, and then plus this last little piece, which is 16 centimeters. All right, and then we just go ahead and add all of that together, and that'll give us 61 centimeters. Okay, now we need to look at the area. So area. Now, there's multiple different ways that you could do the area. Let's just get rid of all of this. Okay, there's many ways you could do this. You could, for example, put a line over, or let's see, you could put a line over there, and then all of a sudden you've got, let's just put 2.4 over there. Then you've got this first shape, then you've got another shape over here, and you've got another shape over there. That's one way to do it. Some other ways you could have done it is you could, for example, put a line over there and a line over there. So then you've got 1, 2, 3 shapes like that. Another way you could do it is, now a very fancy way that you could do this if you wanted to, and if you understand, is you could actually put a line there. Then what you could do is you could see this big shape, that big rectangle, and then what you would do is you would minus this rectangle. That'll also give you the same answer, okay? But I'm not going to do it that way. I'm going to do it like this. And so we've got one shape over there. So that's shape 1, shape 2, and shape 3, okay? And so for shape 1, we have a little bit of a problem. We know what this length is over here, from there to there, but we don't know what this length is. Kevin, it's 9. No, guys, the 9, that's for this whole piece, Okay, so we need to know what that piece is. But that's not very difficult to do, because what we can realize is that this length and this length have to be the same. So that means that this part here is 5.5. So if this entire piece is 9 centimeters, then we could easily work out that part. You could just say 9 minus 5.5, and that would be 3.5 centimeters for that part. And so now we could work out the area of number 1. It would just be this length multiplied by this length. And so that would be 3.5 centimeters multiplied by 16 centimeters, and that'll give 56 centimeters to the power of 2. Now we could, for example, do shape number 2, and so that's this one over here. And so some learners get confused. They're like, must we use this number? Must we use this number? Well, you always have to use one of them going this way and one of them going this way so that it makes a 90 degree. So we're going to use, for example, this one and this one. So we could say 5.5 multiplied by 6.8, and that'll give 37.4 centimeters to the power of 2. Okay, so we've then done this shape, and then we've done this shape over here, and now we need to do this shape. It looks like it's exactly the same. It's going to be 5.5 going that way and 6.8 going that way, so it's exactly the same as this one above. So we could just say 5.5 multiplied by 6.8, and that's also going to give us 37.4 centimeters squared. Now to work out the total area, you just add these three numbers together. So the area is going to be 56 plus 37.4 plus 37.4, and that'll give us 130.8 centimeters squared.